Welcome to Image Processing with ArcGIS Pro. 12 YouTube videos summarize image processing lab exercises available in a step-by-step lab manual that accompanies this textbook. Download the lab manuals at the site shown and obtain more textbook information at the second site shown publisher's website. Download the lab manual and data used in the lab exercises if you want to use the step-by-step instructions and process the imagery and DEMs while viewing the YouTube videos. The examples used in the videos and lab manual are discussed and shown in the textbook, improving GIS student understanding of essential remote sensing principles and technology while learning how to process and enhance images and DEMs using ArcGIS Pro. The lab manual, a page is shown in the upper right, and 12 YouTube videos are designed for GIS instructors, students, and users who want to do their own processing, enhancement, and information extraction of satellite and airborne images and DEMs using ArcGIS Pro. You can see the 12 exercises, the tutorials listed here. They cover a broad range of image processing tasks, algorithms, and help you find where these tasks are located on the various menus in ArcGIS Pro. The lab exercises require ArcGIS Spatial Analyst extension. Contact Ellis at ellis-geospatial.com for any questions or comments, and visit the publisher's website for more information and resources on the textbook. Lab 7 covers georeferencing. You can see images in the textbook on these plates and figures. We're going to do image-to-image georeferencing and image-to-map. And the first exercise is a 1959 scanned aerial photograph to a orthorectified aerial photograph acquired in 2000. The second exercise will be this image to map, where we take a scanned topographic map that has embedded coordinate values and georeference that. And then the third one's an optional exercise about the georeferencing an 1800 wetlands map, which is really interesting. The first thing you do is turn off and remove the streaming online maps, because you have to set the coordinate system for the project as the base image, the one you want to that's already got the coordinates. And there are some issues, so if you have any issues, a lot of times save the GCPs, save the project, exit, reopen. If it doesn't work, you need to start over. So what I've discovered is when you pick 2 or 3 control points, you're building up information in these folders that impacts future work. So if you need to start over and you're going to use the same output folder, you've got to delete these and start all over. The other thing is, the moment you press a couple of these save buttons, this is our scan 59 map. ArcGIS Pro will be making these files. You got to delete these, because that'll continue to propagate error and you won't be able to proceed with the georeferencing. Just some things that I don't see in other software. So first we'll turn these off, and then I think I'll actually remove them. And then you can see our air photo project is over here. Here's the ortho base. We'll drag that over. We want to make sure the view is in the correct map projection. So we'll go to properties and look at coordinate systems, and there we are. So this is what we want to be in, UTM zone 10. Okay, now we're going to drag in the scanned air photo, put it on top. And you see it doesn't show up because it doesn't have any coordinates. So we click on the imagery tab and we go over here to the alignment section and georeference. And fit to display, add control points, the control point table, and these 3 are very important. Save as new, that's when you actually want to create a new georeferenced image from what you brought in the scanned image. This is saving the transformation in an interim command, let's say, and then this is exporting control points. Saving the project does not save these control points. You have to do it separately. Now we will fit the scanned air photo into our frame, into our view, by fit to display. And you can see it shows up pretty well. And we'll go to appearance. And it's very important before you start to look and see if you can find features that are similar. So look in the lower left here, you see that reservoir with the sun glint, and on this side it's black, but that's the same reservoir. You look in the center, you see this very large wetland, vegetated wetland with a meandering stream, and here's that same feature in 2000. It's deteriorated the wetlands, and it's now a ponded water with the meandering stream pretty much degraded. The suburbs here, these are looking for control points, and then try to find, you can see tremendous change in the oil refinery, the Shell oil refinery. So we have to find tanks or something that's in the 1959 and in the 2000, span of over 4 decades. So in the adjust section, there's this add control points, and you can see down in this reservoir there's a pier there, or a dock, and there's the same feature in the 2000. We'll zoom the layer, and you can see it's shifted the image very nicely, so those points line up. Then we'll pick this area, and you can see a meandering stream in this unique pattern, right? So I'm going to pick a control point there. Have to back up a little bit. And the same feature is here. Comes around. See, it's been really degraded, the stream. It's flooded now. And for some applications, just 2 points, it's called scaling, is good enough, but you can see we've rotated the feature. So let's pick some control points down here in the suburbs in the southeast side. You want to see if you can get well-distributed points. And I know up here, if I touch my control key, there's another suburb street that's quite unique. Zoomed a layer. I got 4 points. Now what I want to do is export these points. Oh, I should show you, well, after this I'll show the table. Going to our lab 2, so it's GCPs, be a text file. And I haven't put my control table yet. So here's our actual control points. We have 4 control points. And then I'll go up to this upper left and wrap this up. Oh, I got to touch my C key. And it is interesting here that we can see these tanks in 1959. It's the same tank. And you don't want to pick the top of the tank because we're doing our georeferencing to the bare earth. So you touch this one at the bottom of the tank and the bottom of the tank. Zoom the layer. And we'll say this is good enough for what we want to do. 1 point's really off, 0.2. Ah, yeah. So I want to delete this point. And I picked a control point in the 1959 image. I'll zoom way in. Zoom out. And you can see there seems to be an extra point here that I'll get rid of. But much better fit. We're getting right down to a pretty decent fit on this. So we'll save our file again. And what is interesting, I've noticed, even though it shows up in the directory on Microsoft GCPs 3, I should be overwriting the same file, but I don't see that file showing up here, but I see it over in the directory. And then I want to save the transformation to the 1959. This is why you have to get rid of that. If you're making error, you got to delete a lot of stuff before proceeding. And now we're going to save as new. And this is our export the raster, and we'll name it 1959 georef.tif. And we'll keep everything the same. And just say export. Turn off the JPEG. And this is our scanned image. I can close this table. We've saved that. I can check out the quality by going to Appearance and going to Swipe. Really nice fit. And you can see the tremendous change. So the value of this for historical air photos. I mean, there's a freeway now, traffic jam on 680. Air photos have tremendous value, these historic ones, for checking out what's happened in the environment. How a subdivision is matured, how the groves of trees have disappeared in this lower left. So there's a lot you can do with historic air photos. It's saved as a 3-banded image. I want to zoom to layer. We've got this black band around it that we can get rid of in symbology, a portion of it that's 0. It doesn't work perfectly but it made it much thinner. And those pixels actually had a value of 0. And if I go up to stretch, I can then save this. You can see when I went to stretch, I changed contents to a 1-banded 0 to 255 grayscale image, and I can go to data sharing, export raster. I'll call this 1959 black white. And I'll use the renderer because I turned it into that stretch. And if I turn everything off, that's my new grayscale georeferenced image. Ready to go, 1959, ready to go into any GIS or up on Google Earth or into ArcGIS, Earth, whatever. And so all we want to do is close, save the project, and move on to the second part of this lab. This is the image to map portion of the lab 7. And so we've got a scanned USGS map with coordinates embedded. We'll bring that into this image. We've got the world imagery now as a backdrop streaming. And we're going to locate our site, the search tool. And it's in Port Chicago. And it's the Naval Magazine Memorial. And that'll zoom us in. And then we'll zoom out to a scale of 1 to 100,000. And you recognize this area from Lab 2. It's the NAIP area worked on before. Before we start, we need to establish a coordinate system for our georeferencing. And if we look at the world imagery, we say, what's your properties? Spatial reference. This is only good for the internet and the web and these 3D globes and all that, so we can't use that. We want to use a UTM system. So we're going to change the coordinate system of the view to UTM Zone 10, WGS 84. And the way we do that is we right-click on Maps, Properties, go to Coordinate Systems, and this takes a while. We're going to go to Projected, UTM. You see it's this menu that just keeps on going. Northern Hemisphere, 10 north. And now we know our system is in the right coordinate system. Now the map doesn't appear in the view because it has no coordinate system. So we go back to imagery, that georeference, just like before, fit to display. And here we're not going to be looking for control points on underlying image. That was just help to locate the image. We're actually going to look at these coordinates that are embedded in the image. And you can see the tick marks are accurate for the USGS. The map is cut differently, but the actual coordinates in here. So we're going to add control point, put it on this plus sign, right click, show DMS, and see we just type in 122 7 30 38. You could go 0 0. Well, our map disappeared. Then we zoom to layer and you see it's put it in a better location. Now it's just got to be shrunk down, it looks like. So we'll go up to the same thing, add a control point. Show them in 122. Well, you can only go up to 59, you can't go to 0 0. $38 2, 30. Zoom to layer. See how nicely it's looking like it's fitting? So I'm going to pick some more control points. You can see that in the map there's one up here, one there, and one in the near the center. Here we are, where they actually had tick marks. So these are covering, and this is the more correct location. So I'm going to pick more control points, and then we'll come back to this. These are our 6 control points, pretty low residual. You'll notice that they are offset, and it's 110 meters to the east from the map's margin outline and interior tick marks, and that matches the USGS tick marks at the 4 corners of the entire map. This is just a portion of the map. So then we want to save these, export. They're all enabled. Just put it here. So it's GCP1. And now we want to save as new. So I'm going to save this as a new image, georeferenced image, USGS georef, and it's 5. And the reason I'm putting 5 here is because I'm making the image 25 times smaller by changing my cell size 5 by 5 instead of 1 by 1, which really reduces the size of this image. Otherwise, it's way too big for a lab exercise. And we say, there it is. If I turn off this one, this is our final product. And if I close the georeferencing, I save the edits. You can see once again the value of integrating the imagery. You go to the swipe tool. Now you have names on all these features, but also you can see the tremendous change that occurs. The map was updated 1985. It's in the metadata. But you can see all the changes are in pink. You see the amount of information the aerial photo had. This is a toll booth right there. Toll booth was put in after the map was updated, but you can see all the tanks that have been added. But as usual, the aerial imagery gives you the most up-to-date information. We'll zoom out. Save the project, and we can go back to our output from the previous lab, and let's put the black and white photo in here. And this is where our 1959 photo existed. So we can make that transparent, say 50%. And it's a really informative image showing what was there in 1959 compared to what is on the map. See how this wetlands really shows up in the USGS map with very little update, and on the air photo you really see the change by 2000. So that's a good product to export. So we'll save the project again. We'll cease this part of the lab on the second exercise. The third exercise is an interesting one where you take a map of the wetlands in 1800 interpreted by this group, the San Francisco Estuary Institute, Richmond, California. And you can see with the legend lots of change. And what you can use for the georeferencing is all the infrastructure that they took off the USGS topographic map. So it's a very rapid georeferencing and very informative if you're looking at changes along the shoreline or what's happened to the interior wetlands over the last 200 plus years. And in this historic exercise, there's a Astra satellite image that's really good to compare the value of the different kinds of maps, USGS, interpreted environmental maps, aerial imagery, and satellite multispectral imagery. So with that, we conclude Lab 7.